Hello and welcome, everybody. My name's JP. I've got Zen here with me. And in this podcast, we haven't got a name or anything for the show, but Zen and I had a chat, I think, a few days ago about embeddings and embedding models in particular. And I thought it was a really good chat. And this is a topic that a few people talked to us about, at least to me. So I thought we'd maybe have a chat and record it and see if that's useful for the folks out there who use Weaviate and embeddings. What do you think, Zen? Are you excited?
Super excited, dude. I remember we spoke about this and then we thought this could actually be a really good thing where if we just re-recorded it and put it out there to see if it answers a bunch of questions. I've definitely been getting questions around how do you pick embedding models? How do you evaluate embedding models? How do you run benchmarks? Fine-tuning embedding models. So I remember we touched on a lot of those things. So hopefully this is helpful for people.
Fabulous. Tell you what, and I'm really glad I've got you here with me as the expert, really. So what I'll do is I
I
can
thought
just
when I came into this room, you said you were the expert. What's happening now?
it's opposite days, and
Yeah.
that's why I said it. Uh, so what we can definitely talk about some of that stuff, and I guess depending on who the listener is and how experienced they might be somewhat familiar with the idea of
Yeah.
embeddings and models. I think that's a good place to start. What do you think? Talking a little bit about
Yeah.
embeddings and models.
Yeah, that sounds good to me. I really like your example that you usually give with the colors. So maybe we could start there.
Yeah, okay. Well, I can do. I did a workshop just earlier today when I talked exactly
Yeah.
about this too. Yeah, so an example that I use is colors, right? So I'm old enough to like have used RGB colors way back for like MS Paint and things like that. And that's kind of an intuitive system I think a lot of people would have seen where like colors are represented as like three numbers. And I think for me, using that analogy was good because the idea that people get confused about is hey, you have a bunch of numbers, and these numbers somehow represent like meaning, like quite nuanced meaning too. And I think we bring it back down to say, okay, well, let's think about colors. And RGB systems represent meaning, which is a color with three integers, right? And that works really well. So you can just extrapolate that to, hey, what if we had thousands of these numbers, right? And each number, as opposed to being like an 8-bit integer, is, let's say, a floating point number, or I guess we can talk about what precision they need to be,
Yeah.
later conversation. But yeah, you can represent quite, basically an infinite range of nuanced meanings. And the really cool thing about that is that we can compare meanings too, right?
Yeah. One other example that I really like is the analogy of a library, right? Like if you have a Dewey Decimal System where um, you know exactly where a book should be. If you have a book on like, chemical engineering, you know where that should be in the library. There's a code for where it should be. If you have a book on plumbing, that should be in a different location in the library. And if you go to a librarian, they'll know exactly where to look depending on how you query them, right? I'm interested in a book on cats. They know exactly what part of the library to take that from, right? One thing that is different, like where this analogy breaks down, is in the Dewey Decimal System, we know what each one of those numbers means, right? Like section 500 is for chemical engineering section. I'm just making these numbers up. In the RGB system, we know that the redness, greenness, blueness, and how those combine and everything. But in like dense vector space, we might have 1,000 dimensional vectors. We have no idea what those dimensions mean. We approximately know that they are all equally important, which is an important point. They better be all equally important. It can't be that one thing is super important and everything else is kind of useless. Because a lot of our how we assess similarity depends on them being equally important, but we really have no idea what the 57th dimension or the 42nd dimension actually means. Whereas in the color and the Dewey Decimal System analogy, we know exactly what all the numbers mean. So there is kind of a detail there when we go to neural networks and getting them to give us embeddings.
Yeah, I really like that analogy. And I think Etienne, our CTO, uses like a shopping, like a
Exactly.
supermarket analogy, right?
Yeah.
Which is really cool. And that's a really good segue to talk about not supermarkets, but talk about different ways of arranging these numbers and
Yeah.
arranging meaning. Because if you say, hey, does the meaning of this word, let's say bank, because that gets used a
Yeah.
lot because of different contexts, is that similar to money? And well, it may or may not be. So there's that complexity of what if a word has multiple meanings, how do you disambiguate those? But then
Yeah.
there's also, depending on what you're trying to do, you might want
Yeah.
to organize things differently, right? Like, depending on how a supermarket or a library feels about how things should be organized, they might choose a different system than a Dewey Decimal System, right?
Yeah.
And things might be at different places. And I think that's for me an intuitive understanding of what an embedding model does. It kind of makes some decisions as to what does it mean for something to be similar,
Yeah.
and they then go ahead and perform these jobs in different way with different kind of model architectures.
Yeah. So I think this is super important. Like defining what you mean by semantic similarity. Because in a lot of the talks and the workshops that we do, we kind of just say, semantic similarity is if I showed two things to a human, would they say they're similar or would they say they're not similar? But to be honest, semantic similarity, we don't even understand what is meant by semantic similarity, right? I was watching a talk by Niels Reimers while he was at Hugging Face. Now he's at Cohere, but he goes into this concept of what is semantic similarity, right? And he gives a couple of pretty interesting examples. So if I give you two sentences, right? If I give you a sentence that said, um, the dog was not inside the house, and another sentence that said the dog was inside the house. Now those are negations of each other, right? But are they semantically similar? They're both talking about dogs and houses, and dogs either being in or outside of houses. But a human would say, okay, these are opposites, so they're not semantically similar. Whereas any one of the models that we would use typically would say, oh, these are very similar because, words are similar. Um, so you have to define for your use case, what does it mean for two things to be semantically similar? Another example he gives, which I really liked, was um, let's say you have a sentence that's talking about, I don't know, let's say Michael Jackson dancing, and then Michael Jordan playing basketball, and then you have something like Michael Jackson uh, eating a meal, right? Do you want the semantic similarity to be on the nouns? Do you want the semantic similarity to be on the verbs? There's so many different nuances to what you could mean, and this is why, like, when you're starting off, you can just use any vector embedding model, right? Just to get into the world of vector search, and then once you use that, you kind of have to question, okay, you have to dig deeper and say, what was this model trained to do? And a lot of the base models that OpenAI is trained, Cohere is trained, the open source ones, they're generally powerful. But then once you realize I specifically needed to perform well on this type of semantic similarity, or I really care about this subdomain, now you might have to choose another model, or you might have to fine tune this model to perform better, right? So, like, I think initially when you're getting started, just go ahead, use any model, right? Use a default model, and then you have to say, okay, well, does this model actually measure semantic similarity in the same way that I need it to be measured as well?
I think you've hit like a lot of really like actionable and practical points there. For me, because like a lot of the questions we get is like, hey, I'm not a data scientist. Like, how do I go about choosing an embedding model?
Yeah,
And I think the choice can be really overwhelming for people because, it's obviously a popular area of
yeah,
research and activity for commercially and open source wise. So there's so many models. And I think you've mentioned two things which are really, really valuable. One is choosing kind of like horses for courses, how do you write, identifying your use case
hmm,
and choosing a model that is kind of suitable for that if there is such a specialized model. But more generally, you mentioned, hey, use kind of like the default one, right? Like, so there's like these big either commercial providers or well-known kind of reputable open source models like MiniLM and so on. And to me, those are kind of like really good starting points, right, for
yeah,
people.
yeah, for sure. I mean, the way that I see it, you're probably going to, unless you're doing something that's very generic, um, you probably are going to get a performance boost later on if you do some sort of very specific model picking or specific tuning. But that's way later, right? Initially, you just want to get the thing working. Um, so I was giving a talk a couple of days ago, and for that, the example I used was a medical chatbot. And for a medical chatbot, there's a couple of pretty powerful embedding models. They're called MedCPT embedding models, and so they've been trained to tell the difference amongst like medical domains, right? So the difference between different medications, different diseases, different body parts, anatomy, and so they will do a much better job at differentiating medical concepts than your typical off-the-shelf like OpenAI Cohere model will. Um, but to know that you need that, I think you have to get started with one of these default models and then say, oh, this is not working for differentiating between different medications. And then you say, okay, the solution to that is I need a specialized domain tuned model to do that. Right.
Right. And let me try an analogy if that kind of makes sense. So, for example, like I don't know much about much. So if I read a medical paper,
Yeah.
I can probably understand some of it, and I can probably understand enough about the language in general because I've been speaking English for a fair bit of time, so that I can compare a sentence from that paper to another
Yeah.
sentence and say, well, this looks kind of related to this. I don't know what these terms exactly mean, but I
Yeah.
can, tell enough about the English language so that I can get started there. But then, of course, if I showed it to a medical researcher or a doctor, they would do a better job of like knowing those nuances that are domain
Yes.
specific. Is that kind of fair? Like an analogy between
Exactly.
a general language model and a fine-tuned one?
Yeah, exactly. Another way to think about it is um, if you look at something from far away, you might be able to tell like, oh, this is a medical concept, and that is something about a bagel, right? I have a general purpose understanding enough to know what is about medicine and what is about food, and that's the that's the kind of granularity on which I can distinguish between concepts. But now, if I zoom in and you ask me, well, what's the difference between this medicine and this slightly modified version of this medicine? Well, I have no idea because I was never trained to do that, right? And so now, if you take a medical doctor who has been trained specifically for this, they might not be as good as telling apart bagels than I am, but they're really good at telling apart different medications, different anatomy. And so, and I kind of talking more technically about this, when the way I like to vision it is when you're training an embedding model, you're basically choosing which part you have all the concepts in the world, and depending on the training set you have, you're choosing which part of this concept space to explore and define, right? With these general purpose embedding models, because the people that are training them have no idea whether you want to use them for, I don't know, distinguishing between medication or telling the difference between different laws or bills. They're just training it on like big corpus and different examples. But now, if you're using it for a very specific domain, then it might it might not have a vector space or a concept space that is even well defined. Everything is just blurred in there, right? So you can either go to like a provider like Hugging Face and then choose specifically a model that works for you, or if you have examples of similar and dissimilar things, and you've got enough of those, you can even tune a open source model to work better specifically for your task.
That's Yeah, that makes a lot of sense. Although all I can think about now is where to find bagels. Um, I really like bagels. I suppose there's probably not too many bagel fine-tuned models. Maybe multimodal models, you could get them fine-tuned to distinguish between bagels.
Yeah,
Anyway,
this is a good point. So one now that we're talking about bagels, let me talk about one more domain specific thing. So I was talking to a company in France, and they were specifically interested in differentiating between images of cars from different views, and then differentiating between damage, different types of damage, and where the damage was on the car, right? If you take like clip, it would have no idea, right? The clip can tell you the difference between a car and a bagel, maybe even tell you the difference between a car and a truck, but it can't tell you the difference between a car and a damaged version of that car, right? Especially if the damage is like very small. So that is where you need to that's where you need like a very specialized model to be able to differentiate when you're zooming into vector space and you're saying, okay, these two things are actually not similar. This is a damaged car, and uh, this is
Fine
a
bagel.
perfectly fine car. Exactly. Bagels on the mind.
Bagels on demand, exactly. So, okay, I think we can maybe. So you talked about fine tuning, which is like another sort of super rich topic.
Mhm.
Um, Maybe we can step back a little bit and talk about where people might be able to find these kind of general purpose, good starter type models. We've talked about benchmarks, right? So
Yeah.
what might people want to look for in sort of getting reassurance that these kind of like good starting point models are going to do a good enough job for them to get started with? Like, where would they look? What kind of models
Yeah.
are?
Yeah, I mean, I think honestly, a lot of the people that I talk to, they just go with whatever popular provider they came across, right? OpenAI is a very popular one. Cohere is another popular one. For people that are using open source models, they're using like BGE English Large is a really good one. It's a small model and it performs really well on these benchmarks. But if you're looking to make like an informed decision for the first model you want to choose, I would say like the massive text embedding benchmark, the MTB benchmark from Hugging Face is a good place to look. Um, you have to be careful with that because that benchmark averages across multiple different performance metrics, right? So what their goal is to tell you the best overall model. That might not be what you need. You might just want a model that differentiates cars and bagels. So I don't really care about a model that can tell the difference between a Python function and a Python class, right? Um, but the MTEB benchmark does this like overall averaging of multiple different benchmarks to tell you, okay, this is the best overall jack of all trades model. What I would particularly do is you go to MTEB on Hugging Face, um, look at if your use case matches one of the child use cases, so that you don't get the average score, but you get like a more relevant score to you. And then, honestly, if I was choosing, I would just pick like an open source model that is relatively lightweight, because now there's a lot of these huge embedding models that are derived from like 7 billion language models. Um, I would just choose a lightweight model that I can get up and running really quickly and just start to use it with my data set and see what type of recall I can get, right? Are the relevant things even coming back or not? And then you can have this kind of iterative improvement on, is this model good enough or not? There's another thing to be said about performance on an arbitrary benchmark and then performance on your production level data, like what you really care about, right? And if you don't, I mean, when you're getting started, I think just going with benchmarks is fine, but the next steps are really not worrying about benchmarks and how does this thing actually work on my specific data, right? Because that's what
Mm.
your customers will see.
Yeah, and these benchmarks you were explaining to me when we spoke earlier aren't necessarily a be all and end all because your use cases might be different. And as you said, the benchmarks are measuring all sorts of things that's not relevant to you, right? Like
Yeah,
if I'm remembering the MTB benchmark site correctly, they have a series of these tabs for different tasks.
yeah.
And I think there's only just the one tab for retrieval performance, and the others are like for different types of tasks.
Exactly. So if you go to the MTEB page, maybe when we post this, we can probably post a link to MTEB, and then people can have a look. You'll When you look at the overall ratings, this will be an aggregated score. It's like an average of all the scores. And if you scroll to the right, I don't know how many, but there's like 8+ different individual tasks, one of which is only retrieval, right? And usually, if you're using embedding models with vector databases, you really only care about the retrieval task. Um, and then even within retrieval, like you can go into different types of retrieval. Are you embedding code and doing code retrieval? Are you embedding like different concepts and retrieving those? So I think being specific about what you need will even like, right out the gates will get you a really good model.
Yeah. As you're wearing the Raptors hat, I was thinking in my head, like if I'm playing, I don't know, NBA 2K or something, and I'm picking a team, you really
Yeah,
want to look at the metrics you care about for that position, right? Same kind of
exactly.
thing. if I'm picking a guard who's like, I don't know, very good at what's a useless skill for, probably not too many useless skill for a guard, but if I'm
Yeah.
looking for a center and they're very good at like something that they would never do, like dribbling in the backcourt, it's like, why do I care about this?
Yeah,
Um,
exactly. And if you're using like the MTEB aggregated scores, you're basically saying, give me the best uh, jack of all trades, right? And
yeah,
like I'm going to make a team of five average people who are just average across the board. You're not going to be picking specialists. What you really want to do is pick specialists that are the best for your data. Yeah.
yeah, yeah. And I think from my memory, we can post a screenshot or something of the
Yeah.
MTB when we do this. And they include things like summarization and like for clustering performance for some of these embeddings, which if you're doing vector search with these embeddings are not really all that
Yeah.
relevant at all. So that's like a good place to start, I think.
Yeah.
And the second thing you mentioned when you explained this earlier was really cool when you explained it to me, which was evaluating it on your own data set.
Yeah.
And my kind of worry or understanding when I was thinking about this abstractly was like, hey, how big a sample size or data set would I need to evaluate? How well does it work with my own data?
Yeah.
And you said, oh no, you don't. It's kind of qualitative anyway, right? So you don't need a big data set because you're not doing a benchmark. You're just kind of getting a gut feel or good, gut feel evaluation type thing,
Yeah.
right?
Yeah, exactly. So this is probably one thing. Like I mentioned, a lot of these models on the MTEB benchmark are gigantic and they're derived from language models. So one of the places where where benchmarks can even fool you is if you have a model that's language model based and it might be actually exposed to the MTEB data set. So it might there might be data leakage going on there, and then it performs really well on data because it's seen that data before, right? That's a very kind of egregious example of where that might have happened. But even if let's say the data was not exposed, but a lot of the times the models are trained specifically to perform one task, right? Maybe retrieval, Q&A, given a question amongst 1,000 answers, pick the one answer that answers this question, right? It's been uh, tasked with this during training, so it'll do a good job of this, right? Um, but it might, so that would be considered like within the domain, within the distribution of what that model is good at, but you might not care about that. Um, and so all of your data points would be considered out of distribution. So it would be like training a model to do one thing, but then actually using it for something completely different. Um, and so there, I think the usage of benchmarks kind of breaks down. So then one alternative would be once you've kind of got your pipeline up and running, you've picked the model, um, even if you've just picked a default model to begin with, then actually getting an idea of how well this works is uh, employing some just like playing around with it and seeing how well it works on your data. And a lot of people are doing this now with language models. I don't know if a lot of people are doing this with embedding models. Um, and the reason why they're doing it with language models is because there's overfitting going on everywhere. A lot of these benchmarks are already in the model, and they're kind of the benchmarks don't really matter at that point. So people just say, "We'll play with it, and we'll see how good the results are." Or there's even an ELO system, right, where you have two language models where people give the same question to both language models, and then they say, okay, this is a really high quality answer. This is not that high quality of an answer. If you think about what they're doing there, they're basically getting a gut feel of does this even work? And if you bring that into the world of embedding models, I think how you could do that is I remember we talked about this approach from Andrew Ng in his book where you should take individual if you're training a model to do anything or if you're using a model to do anything, really what you care about are individual examples where the model breaks down, right? And you want to see why it breaks down and how it breaks down there. So the one way you could replicate this is let's say you've got your use case, you understand it, you pick out 50 examples, right? You can just pick out 50 of those, hand label them, what should come back, what should be retrieved using an embedding model, and then you run that through the model and see what actually comes back. And then with 50 or 100, I mean, you can do that in a day and you can make a small data set and you can actually get a good assessment of how well the model is working on your data. It's not going to be as big and fancy as the benchmarks that you have on MTEB, which have like 20 to 50,000 examples, but I think it'll be a good start. And the metrics on this 100 data point benchmark for your data will be a lot more relevant to what customers see when they use this model. Um, and then the other thing that you can do if you want to make it really spicy is you can pick out like 50 to 100 examples, and a lot of people are doing this now. You can give it to a language model, and you can get it to generate synthetic data that mimics those examples. So if you realize that 100 for 100 examples, this model is working well, I can pass it to a language model, do a little bit of prompt engineering, and say, give me 1,000 more examples of this type and give me another 1,000 more examples of this other type until I've covered a lot of the use cases that I think my system will be used in production for. And now you've kind of taken the essence of those 50 examples, and maybe there's 10 of each type, right? So you're testing for 5 things. You've bloated up the 10 into 1,000 each, and now you've got a 5,000 large benchmark that is specific to your data and you can trust, right? So I think there's ways to scale it up as well. But even starting off with 50, I think is a very good start.
And I guess that then gives a bit of a pathway for people to start from, like they might choose a few candidate models, whether it's like from, I don't know, like Cohere or some from Hugging Face and some from other commercial providers. That obviously would work for their use case and deployment possibilities, depending on whether you want it locally or through use inference APIs.
Yeah,
And then they can, for example, look at, benchmarks to select those few and run those small scale experiments to see, oh, actually, this is okay on benchmarks, but let's rule these other ones out because I've run a test with 10, 15, 20 cases and it's just giving me nonsense answers, or it just
yeah,
doesn't look very good for me. And then as a step after that, they can scale up to maybe using synthetic data or more manually created data to do these large scale benchmarks. So it gives a bit of a pathway then.
exactly, exactly. And the best thing that I like about this is that you're getting benchmarks that are relevant specifically to your data, right? So you can actually use those and you can talk to customers about those because it's not arbitrary data, it's your data. It's the recall that the customers will see because it's what they're passing in at test time.
Right. And I can really have a embedding model that I can trust to really know what to do with my bagel language data set
Exactly.
or something.
Specialized. Yeah,
Specialized bagel data set. I think I'm just hungry. I think I just need to eat something before I talk about these things. Um, that's really cool. And I guess like what do you generally advise people about, proprietary or, API based models, which aren't always proprietary, right? Hugging Face
Mhm.
has an API inference thing, but some models are more proprietary and API based versus local inference. What do you generally advise people about choosing between those two generally?
Yeah, I mean, I don't, so I think this is more of a question of what do you want to do with your tech stack, right? Um, if you're serving customers that need like a locally deployed solution, then you have no choice other than using open source embedding models, right? Because at the end of the day, you're going to have to take your solution, you're going to have to containerize it and run it in their cloud, or you're like, that's the only way forward. So then, I mean, I would just go to the MTB benchmark site and I would say, okay, I don't know which model is the best one, but this is my first model, so anyone will do, really. Look for the open source model. Look for one that's preferably not too heavyweight. Get started with a small one and then go from there. The other consideration, like if privacy is not a big concern, right? If you're working with banks or hospitals that don't want to send their data out to have it embedded and then come back, then you only have I think the pathway is pretty clear. If you have more leeway in terms of what you can do with your data or your customers' data, then I think it comes down to thinking a little bit about how those models were trained. So, for example, if you have an e-commerce platform where your product is multinational, right? It's not just in one country. You have multilingual users. So then your embedding model needs to be trained on multilingual data. So then Cohere might be a good example. So to get started with that, I think you don't even have to read the technical reports. You can just look at the value props for these embedding models. Some embedding models are really good for coding. Like Voyage AI has, it's an embedding company out of a professor from Stanford, has really good coding embedding models, and you can find them on the MTB benchmark as well. They're really good. The multilingual models that are the best are Cohere models. So that's another consideration. What does your data look like? Yet another consideration probably would be um, how much if you're thinking about like costs and memory footprint, um, what types of vectors do you need, right? Do you need like quantizable vectors? Do you need vectors that work well when quantized? So that's like a whole different um, thing that we can talk about, but just to give a little bit of a flavor, like the OpenAI vectors are now chunkable. So you can say, I don't feel like using all 3,000 dimensions, so I'm just going to use the first 700, which would be weird because it goes back to what I was saying earlier, where usually when you train these embedding models, uh, every dimension is equally important. So you can't just say, today I feel like using the first 700 and then tomorrow I feel like using the next 700. But with these new OpenAI vectors, they're trained so that as the dimensions go on, they become less important. So if you feel like dropping dimensions, you should drop starting at the end and then going forward. So if you
Yeah,
want that, you should use those OpenAI vectors. Yeah.
that's that those, what's that name again?
Matryoshka,
Yeah,
Russian doll vectors. Yeah.
nesting dolls, right?
Yeah.
Um, I think I intuitively thought when I first heard that, I was like, oh, it's a little bit like, if you're running PCA on
Yeah.
a high dimensional thing, and then you can, you reduce it down to whatever number of dimensions, right? So
Exactly.
it's a little bit like that, but it's pre-arranged for you, so you can just truncate rather than run
Yeah.
another dimensional reduction. You just go, oh, actually, no, they're all ordered in terms of significance already.
Yeah. Yeah,
So
that's a good analogy because like PCA, the first principal component has the most information, like the variance information, and then as you go up the principal components, they get less important. Similarly with the MRL, the earlier you are in the dimensions, the more important it is. Yeah.
that's cool. And yeah, I'd love to sort of pick your brain about quantization and whatnot as well, because you've been talking to Abdel and Etienne and
Yeah.
the research team about that stuff. And that's a really good topic. And I think you mentioned, the size of the vectors too. And I think
Yeah.
a lot of people are going from experimentation to production. And as
Hmm.
their data set size increases, a lot of people are like, oh, this is quite a lot of RAM that we need to store
Yeah.
these indices in memory. So I think that's an interesting topic. And so it sounds like, some of the things that people can do, like choosing smaller models that perhaps don't produce as embeddings that are larger than they need, really
Yeah.
helps with the speed of iteration in development.
Exactly. I think starting off, you want to because when you're starting off, you're probably not just going to randomly pick the best things. So you just want to iterate quickly. So you pick the smallest model and then you get done with your pipeline and you say, how does this even work on my data? And then just iterate over and over and kind of iteratively pick better models, iteratively pick better generative language models as well. I think that's probably the most practical approach. I don't think there is some universal guide to this is the best model and you will never find a better model or anything like that. So
Or unless, like you said, unless you're incredibly lucky and just like know that whatever you pick with a dartboard will be the right one. But unless you're that
yeah,
person,
yeah.
you might want to iterate pretty quickly.
And the rate at which models are coming out, even if you're that person, that like just wait a month and it'll be a better model. So
I guess, yeah, that's a good point. It's like you might have been the luckiest person 2 weeks ago, but
yeah,
by now,
exactly.
2 weeks later, there's like 64
Yeah.
new models out.
Like
Yeah, I think,
2 months ago I was using Mistral the 7X the
mhm,
mixture of experts one,
yeah.
and now I feel like that's like the 10th best open source model now. Databricks, Cohere Commander, Mistral released another one, Llama 3 came out today. It's just endless. So if you go to sleep for like a month and you wake up, your entire pipeline is useless because you're using a month old model, and that's like not going to cut it anymore.
From my perspective, though, it makes me really comfortable with my own ignorance, because it means that everyone's going to be just as out of date with this stuff as I would be by tomorrow. So it's
Yeah.
fine. It's totally fine. Uh, that's cool. I think we've covered a fair bit of ground. Um, Is there anything else that you want to cover while we talk about this topic? What do you think?
Hmm. Yeah, I think one practical thing that people can do is look at their data and then try to Google around and see if there's kind of really low-hanging fruit of if I have multilingual data or I need performance on specific languages, is there a company that's kind of advertising their value prop to be we have embedding models for multilingual data? Or if you're trying to embed code, maybe there is some embedding models that where people are saying we are the best at code embeddings. Um, so I think that's low-hanging fruit where if you don't want to do like a deep dive on this is the best model for multilingual quantized performance, you can just Google around and see which company specializes in multilingual, which company specializes in code embedding. And if you do that, I think the first model you choose would probably even be quite a good model.
Yeah, and the field is certainly getting big enough that a lot of people are specializing,
Exactly.
in one thing or another. I think people used to talk about fine-tuning models a lot more than they perhaps do now. Is that your
Yeah.
impression?
Yeah, I think there is so many models now that um, I don't know. So the incremental benefit of fine tuning a model versus just finding a model that is good enough. I- If you want to like squeeze every ounce of performance, I think you can definitely fine tune on your data, but that's like way further down the line, right? I'm sure you can find a model that's specifically trained for your thing, um, and you can get started with that. So
Yeah, I guess Googling is just a tiny, tiny bit easier than using PyTorch. Um,
exactly.
that's my experience.
Yeah.
Very similar in complexity. Cool. Thanks, Zen. Do you want to wrap it up around there? What do you think?
Yeah, that sounds good to me. I think we've covered a good amount.
Yeah, and I guess like so some of the key takeaways for me would be start with something like MTB to look at what's available, kind of get the lay of the land. Because I think one of the cool things about that benchmark is that it does include closed source or proprietary models,
Yeah,
right? Because they just, all you need to do is, well, it's self-reported for one, which is A,
yeah,
good, and also B, perhaps could be a source of some healthy skepticism.
yeah,
But also it means every single model basically is going to be up there, so you can evaluate all of them, and then
yeah,
start small, iterate, and have a look at creating your own small data sets and going from there. What else did we talk about? I guess like you talked about fine tuning, kind of as like a last steps. Oh yeah, and then looking for like domain specific models that work for you, right?
yeah, exactly. The other thing that doubles into the fine-tuning conversation is if you're evaluating, if you've got a small kind of data set that's specific to your domain, and if you blow it up using synthetic data generation, you can actually that data set that you generate, you might even be able to use to fine tune later on, right? And there's a couple of papers that actually used that fine tuned language models on this synthetic retrieval data set as well. So if you're looking to do that eventually, then I think it doesn't hurt to generate that data set, even if it's initially just for evaluation purposes.
Yeah, there's so many kind of like tools out there. It certainly makes the job easy. So let's wrap up this conversation about there. And I guess I'm not sure exactly what platforms are going to put this video on, but if you
Mhm.
can leave comments, please do leave comments with your questions, or if you liked it, please give us a like. And then I didn't ask you this before we started recording, but do you have anything you want to plug or mention? Any courses you've done recently or anything? Hint, hint.
Yeah,
Um,
so there's a lot of yeah, there we have the LinkedIn course, we have JP's LinkedIn course, we've got deep learning AI courses. There's there's that. There's going to be more work with O'Reilly coming. So we've got a lot of courses. If you're interested, and the good thing about these courses is that they're quite specific. If you want to learn about multimodality, there's a course on that. If you want to learn about like different concepts when using vector databases, we probably have a course on it. JP's Weaviate Academy is loaded with really interesting material. Um, and yeah, if people are interested in this, then I think we can probably even do in the future like a talk on multimodality. How do I pick a multimodal model versus a text model? Because in this talk, we mainly talked about text models, right?
Yeah, I think that's a really good point. And multimodal models are really interesting. And I also just want to do a podcast where people just say multimodal model like endlessly for like half an
Yes.
hour and see how many people get tied up. So let's do that. And I think it could be an interesting one because we can, do more stuff visually too.
Yeah.
So that sounds great. Cool. All right. Well, let's wrap it up there. Thanks for your time, Zen, and thanks for listening, everybody. And
Can you play me an outro tune? Just
I
like
will. I will. I'll do some post-production magic and see how it goes. Do you have any requests for
no,
types
I
of
meant I
music?
meant physically you. Just play
Oh,
the
right. Do 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 do.
that's what I came here for.
That's all I can think of is the Jeopardy thinking music. Yeah, so thanks everyone. And I guess I'm not sure how regularly we would be doing something like this. It's a bit of an experiment. Hopefully you like it. And if you do, and Zen's not sick of me, we'll try and do more of these. So thanks.
Thank you,
All right.
everybody.
Thanks everyone. Cheers. Bye.